So good day, everyone. So this will be the pre-lab discussion of gravimetry, which is the module 3 of CHEM 32.1. And before we begin, we'll have a brief introduction of gravimetry. So gravimetry belongs to the classical analytical methods that relies on measuring the mass of the substance. Okay? So in your module, it is indicated there if the gravimetry belongs to the modern or classical analytical methods. So the modern analytical methods will be introduced to you on the latter part of the course. So the example of this is your spectrophotometry. But in this case, for module 3, we will have gravimetry that relies on the measuring of the mass. So this can also be compared to your volumetry in such a way that volumetry relies on the measuring of the volume. Okay? So we will be introducing to you some common gravimetric methods. So first we have the volatilization. Next will be the extraction, followed by electrogravimetry, and lastly your precipitation. So for volatilization, to give you a brief example, treat this object as your mass 1. And this has a compound, which is a volatile compound. Okay? And after some time, after some treatment that we have done, the initial mass of your container plus sample will be reduced. Okay? Since some of it may have volatilized already. And the vapor that can be collected, okay, if you are to collect this vapor, this can be weighed as your mass 2, okay? Or the final weight of your container minus the sample after volatilization will be treated as your mass 3. And to get the mass of the analyte via volatilization, so this can serve already as the mass of the analyte. Okay? Or we can actually use the mass 1 and 3 to get the mass of the analyte. So we just need to subtract the 2 to get the mass of the analyte. As you can see here, the application of gravimetric methods by getting the mass of the 2 compounds or the 2 containers, we make use of determination of the mass to get the mass of the analyte. Okay? For the extraction, we may have encountered this already in your Chem 40.1 or if you're a Chem major in your Chem 43.1. Okay? For example, we have to extract an alkaloid from tea leaves. So this is your tea leaf. So you have an initial mass of tea leaves that can serve as your mass 1. And after some processes that I will not dwell on, since we are more after the mass of the initial and the final product. So you have a mass here. Okay? So this will serve as your mass 2. And to get the amount of analyte from the sample via extraction, so we can get the ratio of the 2, no? To get the percent yield or percent extract of your method. How about electrogravimetry? For electrogravimetry, we make use of electrochemistry or the application of electricity in your chemical reactions. So in here, we may have 2 beakers with corresponding solutions wherein your electrodes are submerged in your solution. And these electrodes are actually connected to a direct current. Okay? So as you apply current, or as there is an evident flow of electrons in your electrodes, there will come a time that one of your electrodes will be electrodeposited with metals that are present in your aqueous solution. So how do we get the mass of the electrodeposited metals in your electrodes, what we do is first we get the mass of your electrode before submerging it in your solution, and we get the mass of the electrode after the electrodeposition. This will become electrode plus sample. And to get the mass of the sample, we just need to get the difference of the two. Mass of the sample. Okay? So this is your volatilization, extraction, and electrogravimetry. For the context of Module 3, which is the gravimetric determination of iron, what we will be employing is your precipitation. So precipitation is wherein the analyte is separated from the solution of a sample as a precipitate. Okay? And this precipitate will be converted to a compound of known composition that can be weighed eventually. As you can see here, the amount of analyte is determined via measuring the mass of your compound. So all we have here is the masses of your initial and products, initial reactants and products, as we get the mass of your analyte. Okay? And for the context of Module 3, we will be employing precipitation. So what are the general steps of gravimetry? So in this case, we will have 8 steps. So first, we have to weigh the sample, since the initial weight of the sample is very vital in determination of your analyte, or the amount of analyte of your analysis. Followed by the dissolution of sample. Next is the precipitation of the desired component, followed by digestion, filtration and washing, followed by drying, ignition, and lastly, weighing of precipitate product or analyte. As you can see here, we started with weighing of sample to get the mass. And the last step will be the determination of mass as well. Okay? But before we proceed to this, we should have also shown the importance of tearing. Okay? Since before we weigh the sample, we must first tear the container of the sample, which is your crucible. So tearing of crucible involves the heating of the crucible in muffle furnace for 2 hours at 650 degrees Celsius, followed by the cooling of the crucible below redness for about 10 to 15 minutes. Then this will be followed by placing the crucible inside the desiccator for equilibration for another 15 to 20 minutes, and you will weigh this crucible in analytical balance until you get a difference of 2 successive weighings of less than or equal to 0.0010 grams. Okay? And ano bang ibig sabihin ng tearing? Okay? So tearing is just a determination of the constant mass of your crucible. Okay? And before we proceed to that, so let's have a quick view on the tearing of the crucible. Okay. So in this video, we will be introducing to you the tearing of the crucible. So in this presentation, you'll have your crucible here. And we will handle it with tongs. So as you can see, sir, handle the crucible using tongs. And this will be placed inside the muffle furnace. Then after some time, as instructed in your procedure, you will now get the crucible from your muffle furnace. And you have to be very careful with this kasi napakainit ng ating muffle furnace. As you can remember, it is 650 degrees Celsius. So you have to be very careful around the muffle furnace as you get your crucible inside. Okay? And on the left side, we have your desiccators. So all you have to do is place the crucible inside the desiccator after some time. And the manner of doing it is slide off nyo lang yung cover of desiccator. Since the desiccator has grease on its cover and you cannot actually pull the cover from bottom to top. So all you have to do is to slide off the cover of the desiccator and to give you an opening enough for you to put inside your crucibles. Okay? And then you will go to your weighing room for you to weigh your crucible. And by weighing, we just need to tare it. And by tearing, we just need to get the constant mass of the crucible. Okay, so now let's proceed again with our presentation. All right, so after tearing, we'll now proceed with the determination of iron via gravimetric method. So this is the general steps for your determination of iron. So first you have to weigh the sample. Then the dissolution comes in. And then we'll have the precipitation using your ammonia solution, followed by digestion. And after digestion, we will filter it and we will wash it. And then we will ignite it and we will weigh the final product of your analyte product or sample. Okay? So now let's make this into a step-by-step procedure. But before we proceed to that, this is the calculation that you will be needing for the final product or final answers. So in here, you are required to get the percent iron and percent ferric oxide. And for you to do that, you need to get the mass of your ferric oxide and the mass of your sample, your initial sample. And you will have to multiply it to 100 to get the percent ferric oxide. And for you to get the percent iron, you will apply the GF, which is your gravimetric factor. Okay? And this gravimetric factor is just the ratio of your weight sought over weight weighed. Okay? So ano ba ibig sabihin ito? So let's proceed to the next slide. So your GF is just the ratio of your formula mass of substance sought and the formula mass of your substance weighed. And your A and B are just whole number coefficients that would balance the element of interest. So for example, in our case here, since the element of interest is iron, all you have to do is to balance the iron in your numerator and your denominator. So for you to do that, your A should be equal to 2 and your B should be equal to 1 to balance out the iron present in your gravimetric factor. Since you have 2 iron here and 1 iron here, you have to multiply your numerator to 2 and you have to multiply your denominator to 1. And the weight here is your formula weight or the molar mass of your substances. So we have two substances, you have the substance sought and the substance weight. Okay, so now let's proceed to the step-by-step procedure of our gravimetric determination of iron. So the first step will be the weighing of sample, and it is just by weighing by difference. So now let's proceed to our video to show you the weighing by difference. So as a review for weighing by difference, you have to weigh first the container plus sample. So you will get its weight. And then you will have to transfer the content of your sample to another container by tapping. Okay. So this is how you tap your sample from another container to the beaker. And after tapping, you will have to remove, you have to place back the cover of your container and you will weigh it again using your analytical balance. Okay. So the next step will be the dissolution of your sample using your 6-normal hydrochloric acid and concentrated nitric acid. So what is the function of 6-normal hydrochloric acid? So the 6-normal hydrochloric acid liberates all the ferric and the ferrous ion in your sample. So if you have a sample and you add 6-normal HCl, what happens next is the resulting solution will have your Fe2 plus and Fe3 plus. Okay? So what happens next is for you to add your concentrated nitric acid. So what happens here is the liberated Fe2 plus upon addition of nitric acid will convert your Fe2 plus to Fe3 plus. Okay? So ano bang essence nito? The form of Fe3 plus is the desired form of iron as we do the whole process of gravimetric determination of iron. Okay? And the addition of nitric acid must be done under the fume hood since the addition of it to your ferrous ion have a subsequent consequence of producing a poisonous gas in the form of nitrogen monoxide. And excess nitric acid assures that there is a full conversion of ferrous to ferric with no backward reaction happening. And this is the corresponding pertinent equation that is essential for you to determine the conversion of your ferrous to ferric. And as you can see here, there's a subsequent evolution of gas. So this is your poisonous gas. So I think this is part of your pre-lab questions on how or why you have to conduct the addition of nitric acid under the fume hood. So you must have indicated there or specified that there is a production of poisonous gas in the form of nitrogen monoxide as you convert your ferrous ion to ferric ion. So again, let's go back to our video presentation for the addition of 6-normal hydrochloric acid and subsequent addition of concentrated nitric acid. So in this case, we will be dispensing distilled water that will serve as your initial solvent for your sample. And then using a separate pipette, you will be transferring 6-normal hydrochloric acid to your aqueous solution. So again, the purpose of adding hydrochloric acid is for you to liberate the Fe2 plus and Fe3 plus present in your solution or in your sample. And you can see there that there's a change of color in your solution. And then you will stir it and put the solution in the heating pan. And you have to add slowly filtered 6-normal ammonia solution. So bakit kaya filtered? Because ammonia, when stored in glass container, tends to produce silicates. Okay? So yung mga silicates na yun may interfere with your precipitation of your compound of interest. And for you to avoid that, you have to filter first your ammonia solution prior to usage in your dissolution part. Or digestion part, rather. So in this portion, we will be adding your nitric acid. And then you will dilute the solution using distilled water. Okay. So now let's go back to our presentation. So after addition of nitric acid, we make sure that it is in excess. Okay. So that the backward reaction of Fe3 plus to Fe2 plus does not happen. So now let's proceed to the precipitation of the desired component. So as mentioned, we will be using ammonia. And this ammonia will have a corresponding reaction with Fe3 plus, producing your ferric hydroxide hydrous precipitate. Hydrous meaning there is water adhered on your precipitate. So this forms a reddish brown gelatinous precipitate that will be shown to you in this video. Okay. So as you can see here, once the drop has contacted the solution surface, there will be a change of color to reddish brown. So from clear bright yellow solution to reddish brown gelatinous precipitate. So as you can see here, there are precipitate that are floating around the solution or the mixture. And this is the final appearance of your mixture after addition of your ammonia. So this is the procedure after your digestion. Okay. So now let's proceed to the next part. Actually, that is your precipitation part, sorry. Now let's proceed to the next part, which is your digestion. But before we proceed to that, let's just focus more why we chose ferric ion instead of ferrous ion. So in ferric ion, in the form of ferric hydroxide, the KSP value is 8 times 10 to the negative 38. Whereas for ferrous hydroxide, it is only the KSP value is equal to 8 times 10 to the negative 6. Okay? So the higher the KSP value, the more tendency it is to be more soluble in the solution. As you can remember, we need the compound of interest be precipitated. And this can only happen if the KSP value of our desired precipitate is very low. So a very low value of KSP is desirable for us. That's why we make use of iron in the form of Fe3 plus. So this is your Fe3 plus, this is your Fe2 plus. So mas mataas yung tendency ni Fe3 plus na mag-precipitate rather than Fe2 plus. Okay? And then why do we use NH3 as a precipitating agent? So NH3 is used to control the OH minus concentration, kaya hindi strong base yung ginamit natin, weak base lang. And by using a weak base, we may prevent the formation of other hydroxides, oxides, or basic salts. And by doing so, we can only have the ferric hydroxide present in our mixture. And why do we have to filter the aqueous ammonia solution? It is to prevent the introduction of silica. Because if you didn't filter it prior to use, your NH3 may have silicates or SO4 2-. And this SO4 2- can react with your Fe3+, forming your Fe2SO4 3. Okay? So kapag na-form tong ganitong kind of salt, so ano nangyayari? So we cannot account for the iron that bind with SO4 2-. And by then, since this is gravimetric determination of iron, so if we cannot account for iron loss because of the introduced silica in our solution, so there are many rooms of error because of this. And to avoid that, and to minimize that error, we must filter first our ammonia solution to prevent this from happening. Okay? Because when this happens, we cannot account for the iron, or there will be a loss of iron in the process. So what are the desirable properties of precipitate? First, it must be easily filtered and washed free of contaminants, followed by sufficiently low solubility. As you can see here, this is a more, it has less solubility than the Fe2+. Then this must be unreactive to constituents in the atmosphere. Number 4, this must be of known chemical formula. Number 5, it has a small mass of analyte, should yield a large mass of precipitate. Okay. So how do we test for complete precipitation? So how do we know if all the Fe2+ or Fe3+ present in our solution has already precipitated out? So if you can smell the odor of ammonia, that means that complete precipitation has already happened. Or you can make use of litmus paper when the test becomes red to blue, meaning the solution or the mixture is basic. Or if the supernatant is already clear as you add your ammonia. So allow the precipitate to settle, then add precipitating agent. So if there is a formation of precipitate, so ibig sabihin, incomplete pa yung precipitation natin. But if there is no formation of precipitate as you add the precipitating agent, hence the precipitation is already complete. So what happens to the precipitate formation here? So we have here the nucleation and the particle growth. So the desirable precipitate formation is the particle growth. By particle growth, it means the precipitate with large particle size is the one being observed, rather than the colloidal precipitate, which is can be formed via nucleation. Okay? So ang desired natin dito sa ating experiment is yung particle growth. Okay? So what are the factors affecting the particle growth? So this comes your von Weymarn ratio. So the RS refers to your relative supersaturation. Your Q refers to your concentration of solute. Your S refers to your equilibrium solubility. So our aim here is to lower the RS value. So how do we lower the RS value? By having a high value of equilibrium solubility and a low value of concentration of solute. So by doing so, a low value of RS pertains to large particle formation due to particle growth. Whereas a high value of your RS pertains to colloidal precipitate formation via nucleation. Okay? So the next step will be your digestion. By digestion, it means your precipitate. We will have to boil your precipitate for another minute, and we will allow the precipitate to settle. So let's view the video again for the digestion portion. Okay, so for digestion portion, you just have to continuously boil the mixture for another minute. Okay, so what is the purpose of this? So digestion refers to the standing of the precipitate in the presence of the mother liquor, which is your acid. And the purpose of this is for you to increase the crystal size via particle growth through coagulation. Okay? So part of your pre-lab questions is what happens if you prolong the digestion. As mentioned from your procedure, digestion must be done for exactly 1 minute. Okay? So prolonged digestion meaning the digestion was done more than a minute. So by prolonged digestion, it just means that the increased crystal size will revert back to its colloidal form. So let's have a quick timetable here. Okay. So let's have your precipitate here. Okay. So this is during the pre-digestion part. So for during digestion in a span of 1 minute, the smaller precipitate tends to clump together via coagulation. So this can become like this, as if they appear as if they are a bigger precipitate. So ideally, after digestion, the coagulated precipitate via increased crystal growth should appear as a bigger precipitate. Okay? However, during prolonged digestion, it will revert back to its colloidal form. Okay? In colloidal form, they are in a very small particle size. And this phenomenon is called your peptization. Okay? So peptization is the phenomenon that happens during prolonged digestion. So it is just like the reverse of coagulation. By coagulation, you increase the crystal size. By peptization, you go back to its colloidal form in the smaller crystal size. Okay? So after digestion, we'll now proceed to filtration and washing. So by filtration and washing, the bigger particle size of your precipitate will be filtered while hot, and it will be washed by ammonium nitrate, which is your washing reagent. So why do we have to filter our solution while hot? So this is to avoid prolonged digestion, since this will improve the flow rate of our filtration, since the filtration will allow you to separate the precipitate from the mother liquor. Also, this will avoid the hardening of the impurities when mixture gets cold. Okay? Also, why do we use ashless filter paper? Since we have to avoid the positive error during ignition contributed by the ash. Okay? Since the last step of our procedure is ignition before weighing the sample, so the ash that must be present in your ignited sample must contributed 100% from your sample itself. So if you use a filter paper that is not ashless, so there's a contributory ash from the filter paper which we cannot account for. Okay? That's why during the filtration part, we will be using ashless filter paper. And the washing using ammonium nitrate is for us to remove the impurities or the interfering ion. So your ammonium nitrate is an inert, neutral solution which will not interfere with your precipitating or precipitation, digestion, or whatever process that you have already undergone. Okay? The only purpose of this ammonium nitrate is for you to remove any impurities that may have adhered on your precipitate. Okay? So now let's proceed to the video viewing of the filtration and washing part. So this is your setup. So as you can see here, as you reheat the mixture, while there is pending filtration happening on the other side, notice that your ammonium nitrate is being heated for the next step, for washing part. Since you have to make use of a hot washing reagent as well. So if you use cold, this may result in premature recrystallization of your precipitate, and this will impede the whole analysis. So by washing, meaning we will apply the ammonium nitrate in our beaker to quantitatively transfer the whole content of your precipitate to your filter paper, since there are residues present on the side or the wallings of your beaker. So para lahat ma-account natin. As you can see, even the one adhered on your steering rod is also being cleaned and washed so that we can account for all the iron present in your sample. So this is the final view of your setup before after the filtration and washing procedure. Okay, so now let's proceed to the next steps. We'll have your drying and ignition. For drying, since we have the precipitate in the form of ferric hydroxide, hydrous, we just need to remove the hydrous part. Okay, and by removing the hydrous part, that is the drying part. Okay. By drying, we will introduce our precipitate in an oven at 100 degrees Celsius. Actually, at 105 degrees Celsius. Why 105? For us to remove the excess amount of water present in our precipitate. So, kanwari, ito yung ating precipitate na naka-zoom view. Okay? And treat the green dots as your water that is adhered on your precipitate. Okay. So the drying part, as we introduce our precipitate in the oven, our aim is for us to remove the adhered water in the precipitate. So most probably, the green one will evaporate kapag na-introduce na siya sa 105 degrees Celsius. But complete drying of your precipitate may not be achieved since there are water trapped inside the gelatinous precipitate of your ferric hydroxide. Yun yung mga nasa loob nito. Yan, yung mga nasa loob. And for us to completely remove the water, ignition may be used for us to completely remove water and convert our precipitate in a weighable compound in the form of ferric oxide. Okay? So you may ask, bakit hindi na lang po diretso natin siyang i-ignite? Okay? Ba't kailangan pang dumaan sa drying? So again, for the ignition part, it involves the use of high temperature. Okay? So as you can remember, your sample is enclosed in a crucible. If this is your crucible and this is the cap of the crucible, your sample is inside this one. So this is your sample. So if you subject our sample inside the muffle furnace, so there is a tendency that splattering may happen since there is a build-up of pressure here. So what happens is, upon opening the muffle furnace, you can see there that your sample is all over the place inside the muffle furnace. So, ang tendency nun is, wala kang mamuwi after, or there is a negative error in your procedure. And to avoid that, we have to first remove the water content using drying method as you subject your sample in the oven. So magkaiba yung oven tsaka furnace ha. Okay? And in this case, as you remove the water via drying and ignition, your ferric hydroxide hydrous will become your ferric oxide and your water will be dissipated as a vapor. Okay? So now let's proceed again to our video presentation. So dito, i-fold natin yung ating filter paper with precipitate as we put it in our crucible. And then we will dry it in an oven at 100 degrees Celsius for 3 hours. So this is the oven in our institute. Yeah, be very careful with this kasi may tendency na pwedeng mabitawan mo yung crucible, mababasag, yan. Eh yung crucible na yun, yun yung teared crucible mo. So yun, uulit ka ng tearing if that happens. So you have to be very careful with this. And again, this is hot. 100 degrees Celsius yan. So you have to be very careful as well. Then after drying, we will subject it to muffle furnace for ignition. And again, ang ignition ay at 650 degrees Celsius for another 3 hours. So medyo matagal yung ating experiment, no? And after that time, we will have to remove it and we will weigh our crucible as if nagte-tear ulit tayo. So ganun yung ano natin. Manner of weighing. We will get the constant mass of our sample as a form of weighing the final product. And then you will have to transfer it in the analytical balance and wait for the final weighing. And this is the presentation or the illustration of your ash after ignition. Okay, so now let's proceed again with our presentation. Again, for the calculation part, you will have to use the percent ferric oxide by getting the ratio of the weight of the ferric oxide. This is your ash. And this is your initial sample. And again, for us to get the percent iron, you will have to apply the gravimetric factor for this analysis. So for the answers to pre-lab questions, first, why should the addition of concentrated nitric acid be done under the fume hood? So we have already answered this part, no? You have to put these under the fume hood so that you avoid the inhalation of the poisonous gas in the form of nitrogen monoxide as you convert your ferrous ion to ferric ion upon addition of nitric acid. Then why is it necessary to filter 6 normal ammonia? Since your ammonia, when stored in glass container, it reacts with the glass to form your silicates. And your silicates may interfere with your analysis. That's why you have to filter your 6 normal ammonia prior to use. Okay. Number 3, what is the effect of prolonged digestion? So the prolonged digestion will lead to peptization, which is the reverse of your coagulation. So instead of having a bigger particle size crystals or precipitates, what happens is it reverts back to its colloidal form, which is the form of smaller particle size. Okay? Why is filtration of gelatinous precipitate done while the solution is still hot? This is to engage or to promote faster filtration since when the solution is hot, the viscosity of the mixture becomes lower, and a lower viscosity means a faster flow rate, and a faster flow rate means a more rapid filtration, since this will further avoid the prolonged digestion of your sample if you are fast enough to filter it. Okay? Then lastly, why should you use an ashless filter paper? And this is for us to avoid positive error, since there will be contributing mass that will be coming from your filter paper after ignition. So the final mass that will be accounted for will just be coming from your ignited precipitate in the form of ferric oxide. Okay, so now let's proceed to our sample problems. First is from the feldspar sample weighing 500 grams of a mixture of potassium chloride and sodium chloride was obtained, weighing 118.0 grams. Subsequent treatment of silver nitrate furnishes 245.1 grams of silver chloride. So what are the percentage of sodium oxide and potassium oxide in the sample? Okay? So try nyo muna sagutan to on your own, and you may pause this video, and then later on, I will show you the sample calculation. Okay? So here comes the sample calculation part. As you can see here, you have a sample of feldspar. Okay? And this sample weighs 500 grams. And you have treated this feldspar and upon treatment, you yield to mixture of NaCl and KCl. Okay? And the mixture of NaCl and KCl is around 118.0 grams. Okay? Then afterwards, there is a subsequent treatment of silver nitrate to your mixture. And this forms your AgCl. upon addition of silver nitrate. Okay? And this silver chloride weighs 245.1 grams. So your question here is, what are the percentage of sodium oxide and potassium oxide? So as you can see here, we can have a representation of our variables. So let X be the mass of NaCl, and let Y be the mass of KCl. So our first equation will look like this. We'll have X plus Y equals here, 118. Kasi nga, yung mixture of NaCl and KCl is 118.0 grams. Okay? And then on the next representation, number 2, what will be our next equation? Since we have two unknowns, we can apply two equations to unknowns. Two equations, two unknowns. Okay? So for the second unknown, we will apply here our gravimetric factor. Okay? Since we have a mass of NaCl, and as you can see here, there is AgCl as a final product. But the gist here is there are AgCl that came from your NaCl, and there is AgCl that came from your KCl. Now you have to determine the amount of AgCl that came from NaCl and KCl separately. Okay? So the mass of NaCl, you have to multiply it to your GF. So what is your GF here? So your GF here is the mass of your formula mass of your substance SiO₃. So your substance SiO₃ here is your AgCl over the formula mass of your substance weighed. So your weighed substance is your NaCl, since you have a mass of NaCl. And this will be multiplied to the coefficients A and B. And since our compound of interest is chloride, and their correspondence is 1:1, so our A and B here are both 1 for AgCl and NaCl. Okay? So in essence, our equation here will become the mass of AgCl from your NaCl is X multiplied to formula mass of AgCl over formula mass of NaCl. Plus, ganun din yung gagawin natin for your KCl. Since there's a corresponding mass of KCl, i-multiply lang natin siya sa formula mass ng AgCl and formula mass ng KCl. Based from the problem, the resulting AgCl will be 245.1 grams. Okay? So, ang ating formula weight or formula mass for AgCl, NaCl, and KCl are the following. So we have for AgCl, 143.321 grams per mole. For NaCl, we have 58.442 grams per mole. And for KCl, we have 74.551 grams per mole. Okay? So all you have to do is substitute these values here. Then, substitute nyo rin tong ating NaCl dito. and KCl dito. And then use your calculators, your equations. Just click the mode, tapos equation, then yung ganitong form, A x plus by equals C. Okay? Let me check kung ganito nga yung form natin sa calculators. So sa calcu, meron pa palang n sa gitna. So ANX plus BNY equals CN. Okay? You may choose that and just enter the coefficients of your equation. So dito, you have 1, 1, and 118. And for the second equation, you have the ratio of the two. You have the ratio of the two and 245.1. And you will get the value of x and y to be equal to, ang x natin ay yung NaCl, so this is equal to 34.44040,261 grams NaCl. And for KCl, we have 83.5595,739 grams KCl. So to check, dapat yung sum nitong dalawang to ay equal to 118.0 grams. Okay? So now, the question here is, what are the percentage of sodium oxide and potassium oxide? So now we will be using again your gravimetric factor, your knowledge on your GF. So all you have to do is, for you to get the Na2O, you have to make use of the mass of your NaCl. So 34.44040261 grams NaCl. I-multiply natin siya sa GF. Ang GF natin is formula weight ng substance salt, which is your Na2O, over formula weight of substance weighed. Ang na-weigh na natin is your NaCl. Multiply to its coefficient. And ang ating coefficient dito is, ang compound of interest na natin dito ay yung ating sodium. And if you can compare this, you have 2 sodium here and you have 1 sodium here. And to balance this out, you have to put 2 here and 1 here. Okay? So in essence, you have grams of Na2O here. And then, after which, you will divide this to your mass of your sample, multiply to 100. Okay? So the percent Na2O is equal to 3.65 247.8891%. And following the correct number of significant figures, it is approximately equal to 365% Na2O. Okay, same will be done for your K2O. Percent K2O. So this is just equal to 83.5595739 grams KCl multiply to the GF. So ang formula weight salt natin ay yung K2O and ang formula weight weighed natin is your KCl. Again, your compound of interest will become your potassium, and to balance it out, you have to put 1 in your numerator and 2 in your denominator. Divided by the initial mass of the sample, multiply to 100. And to check, that is the final answer here is 10.557734%, or approximately equal to 10.6% K2O. Okay? So, as a guide, you just need to get also the formula weight of your Na2O and K2O. So, madali lang yan, no? Pagkuha lang ng molar mass. So, ang Na2O natin ay 61.979 grams per mole, while your K2O is 94.195 grams per mole. Okay? So, I guess your answer shall be 3.65% Na2O and 10.6% K2O. Okay? So, next sample problem. Ayan. So, we have a 0.350 gram sample of commercial phosphate detergent ignited to destroy the organic matter. Then the residue was taken up in hot hydrochloric acid, which converted your phosphorus to phosphoric acid. The phosphate was precipitated as magnesium ammonium phosphate hexahydrate by the addition of magnesium 2+, followed by addition of aqueous ammonia solution. After being filtered and washed, the precipitate was converted to Mg2P2O7 by ignition at 1000 degrees Celsius. The residue weighed 0.2161 grams, and your question here is calculate the percentage of phosphorus in the sample. Okay? So now let's go back to our sample problem, no? So you may actually calculate on your own that problem. And then to check, this is the sample calculation. Okay? So what actually happened here is you have a feldspar. You have a phosphate detergent sample of 0.351 grams. Detergent sample. Okay? So what happens here is nagkaroon ka ng dissolution. Okay? Dissolution part using your HCl so that your phosphorus will be converted to H3PO4. Okay? After which, the phosphate will be precipitated as magnesium ammonium phosphate hexahydrate. And this is via precipitation. Okay? Yung precipitation natin is done by the addition of Mg2+ and ammonia. So ang form natin ngayon will become MgNH4 PO4 6H2O. Okay? And after precipitation, a series of procedures are done. And lastly, it was ignited. After ignition, the final form of your ash is in the form of Mg2 P2O7. And your task is for you to calculate the percentage P in the sample. Okay? So what we're going to do now is to deal with the given. So we have here 0.2161 grams of Mg2 P2O7. Ang next natin gagawin is for us to multiply our given to our GF. Okay? Ang GF natin ay formula weight SiO₃. So ano ba yung kailangan natin? Formula weight ng phosphorus. Divided by formula weight weighed. Ano ba yung na-weigh natin? Ang na-weigh natin ay yung Mg2 P2O7. Okay? And this will be multiplied to its corresponding coefficients. So the element of interest here is your phosphorus. And to balance it out, you have to multiply 2 in the numerator and 1 in the numerator. So that meron kang dalawang phosphorus dito and dalawang phosphorus din sa denominator. Okay? And then, what we're gonna do next is for us to divide the whole expression to the mass of your sample. And this will be multiplied to 100 to get the percentage. So for your reference, the formula weight of phosphorus is equal to 30.974 grams per mole. And the formula weight of Mg2 P2O7 is equal to 222.551 grams per mole. Okay? And as you plug in the values that we have here, you'll get 17.137418.01% phosphorus. And as we follow the correct number of significant figures, we will report it as 17.1% phosphorus. Okay? And to check our answer, 17.1%. Okay? So for the summary of our module 3, what we did is we determined the amount of iron via gravimetric method. And first, there are 8 steps for us to determine the iron content. What we did first is to weigh the sample. Weighing of sample. And this is done by weighing by difference. Okay? Since we have 2 types of weighing, no, we have weighing by addition and weighing by difference. In this case, what we did is weighing by difference. Next is we liberate our Fe2 plus and Fe3 plus using our HCl solution. Ang step 2 natin ay dissolution part. Again, your HCl is used to liberate Fe2 plus and Fe3 plus. And then your concentrated nitric acid converts your Fe2 plus to Fe3 plus. But its conversion has a subsequent evolution of gas in the form of NO, or your nitrogen monoxide. That's why the addition of nitric acid must be done under the fume hood. Okay? Then after dissolution, what we did is step 3, precipitation. By precipitation, we make use of filtered 6-normal ammonia solution. So why did we filter? To remove silicates. Since your silicates may interfere with your solution, since silicates may form precipitate with your ions. Okay? Also, why NH3? So the weak base is used in the form of NH3 to control the concentration of OH minus. Why do we need to control? So that we prevent the precipitation of other oxides and hydroxides that may be present in your sample. Okay? So after precipitation, we'll have digestion. So digestion for exactly 1 minute to promote crystal growth or via particle growth. Promotes particle growth via coagulation. Okay? And if you prolong the digestion, what happens is peptization. So peptization is the reversion back of your precipitate to its colloidal form. So we don't want to do that. And then we allow the precipitate to settle and we will filter it while hot. So why do we filter it while hot? Since pag mataas ang temperature ng ating solution or mixture, bumababa yung viscosity. Hence, mataas yung flow rate. Pag mataas yung flow rate, faster filtration, less tendency for prolonged digestion. Okay? So this is your step 5 and 6. Filtration and washing. For step 7, we have here drying. By drying, we subject first our sample in the crucible in an oven for 3 hours at around 100 degrees Celsius. And then after drying, we will ignite it. Ignition. 1, 2, 3, 4, 5, 6, 7, 8. Okay, mali ako. So this is only step 5. This is step 6. This is step 7. Ang step 8 natin is weighing of final sample. Okay? By weighing of final sample, we can now compare the weight of our ash to the initial mass of the sample. And by then, we can use this as the aspect of gravimetry since we make use of the mass of your product and your initial reactant. Okay? So this is the summary of the determination of iron via gravimetric method. Okay, so this ends the presentation for gravimetry. So thank you for listening, and I hope you have understood the steps starting from the weighing of sample until the ignition part. Okay, so thank you for listening.